Good morning, everyone. My name is Pedro Alves, and I'm here to guide you on a journey into distributed tracing. Before I start talking about the rollout, I wanted to explain why I'm here. This is a photo from 2019, where a few colleagues and I were here running a workshop on open tracing. We covered open tracing basics, hands-on instrumentation, troubleshooting. And we got to the end of the workshop. We said, OK, so who has questions? And we were waiting for questions around the content of the workshop. Turns out mostly everyone wanted to know how we rolled out distributed tracing in our organization. I was not ready for that line of inquiry, but 4 years later, here I am. But because rolling out new technologies is something that companies do a lot of, I thought that this would be a good opportunity to see some key learnings that we could use to roll out other technologies. So let's put some context. This company was running 3,000 to 4,000 services. We had an engineering population of over 1,000 people, different types of services, different types of technologies and runtimes. We were fresh out of the move to microservices in the cloud. And most of the events took place around 2018. The whole thing started with asking ourselves, do we have the right tools? The right tools for what? So even though we moved to microservices and the cloud, we were still monitoring the applications the same way we were doing in the data center. So new architecture, old practices for monitoring. We did try to bridge the gap in a few different ways, propagating a flow ID that we were already using to grab all the logs for a given transaction. We propagated them across service boundaries. We tried a few different APM solutions running with some services, collecting metrics and some sort of tracing. We got a new logging tool. We had a legacy metrics tool that was still working. We just need to add a few more features and support for new data sources. But whatever we did, we kept hitting limitations. Logs were siloed in team accounts, so the log ID would cross service boundaries, but you can only query for logs within your own team services. APM solutions were limited in terms of coverage for the runtimes that we were using, so we always had a big portion of the platform that did not get the visibility from those solutions. And our growing service count meant that the legacy monitoring metrics tool kept hitting limitations around storing and querying time series data. This mostly affected reliability through incident handling. So teams were alerting on siloed signals. Most of those signals would lead to false positives or red herrings. Troubleshooting required constant hopping between teams. Hey, what's happening in your service? What do your logs tell me? Oh, well, give me something to search for. Oh, I'm seeing something in my dashboard. Well, that's not what I'm seeing in my dashboard. From a different perspective, our monitoring practices were missing a few key ingredients. Causality. We had isolated data points, isolated events, nothing establishing concrete links between two signals. Democratized, I mentioned the siloed logs. Metrics were available to everyone, but because everyone would choose different naming patterns for metrics, different aggregating functions, or would measure things in different places, think application or load balancer measuring HTTP status codes, discoverability and understanding metrics was a bit challenging. And it would also be good to have something that would give us some golden signals out of the box. Ultimately, our goal was to be able to understand the flow of requests across our distributed system. We wanted to see how all of those services were interacting, how, if there was an error, where was it coming from? If there was a latency spike, what was the main contributor? And we found the answer to these problems in distributed tracing. Okay, so we started with a problem. We found a potential solution. We need to figure out if this actually works, as we expected. Moving to the experiments, we did have one strict requirement. It had to be open tracing compatible. The reason was strategic. We had gone through experimenting with a few APM vendors. And whenever we had to change from one to the other, there was a big cost of re-instrumenting the entire platform, or whatever that APM solution covered. And we wanted to avoid that cost, so using an open standard made that easier. The service instrumentation would remain the same. In the case of open tracing, we would have to change the tracers and redeploy the entire fleet, which would still be a big effort, but it'd still be less than what we saw before. Today, with OpenTelemetry and the collectors architecture, that would be even easier. But there were other benefits with using industry standards. Because you had a standardized data model, it would be easier to plug in different tools that could work with that data. Semantic conventions that would help us establish, give guidance on how to instrument and how to represent certain signals and certain concepts, and a wealth of industry knowledge available. Okay, so experiments mostly mean a proof of concept. In this proof of concept, we were collecting answers for 3 questions. What is the best tool to have distributed tracing in our company? So we set up some open source tooling. We tried different vendors. We also tried to understand, will this technology actually solve our problems? So we instrumented some services to see how tracing would look like in our setup. We ran game days measuring time to recover, which admittedly did not go as well as we expected. We did not get the learnings that we were looking for. And also, is it compatible with our scale? So we ran some load tests to see if, okay, at our scale, will this hold, or what kind of issues will we face? Regarding picking the right tool, there's a lot to say here. There were some things that we were evaluating each tool. There's also a question of build versus buy, which depends a bit on your company, if there's an engineering strategies to say one or the other. But regardless, there are a couple of criteria that you should use. Costs. That's not just a vendor fee. There's also staffing. There's some sort of infrastructure that you have to maintain. What kind of expertise would you need in your company? What kind of scale can that tool handle? If it handles your scale and your predicted growth. Feature set. Does it have the features that you want? Does it have features that you didn't even know you need, but now you want them? And if it's customizable, do you have to change your processes to fit the tool, or can you change the tool to fit your processes? So we get to the end of the POC, you need to make a decision. Team went with buy, so we used a third-party tool. The team was already maxed out with running the infrastructure for metrics and logs. And we also need to get an okay from management. So that means, okay, we present the POC outcome, what are our learnings, our recommendations. We define some expectations on return on investment. So we're going to do all of this, and what do we get out of it at the end? Which mostly meant reminding the challenges that we were facing, those siloed signals that were alerting on-call teams, the constant hopping between teams to troubleshoot an incident, how this affected the reliability, and how we could see distributed tracing help address those issues. Okay, so I'm here, so you may have guessed that we got the green light. So now it's time to start working on the rollout. At the time that the POC was about to be wrapped up, there was an SRE team that was being bootstrapped. And that team was actually the one that was put in charge of rolling out distributed tracing to the rest of the engineering organization. That's actually when I got into the project. This did not come out of the blue. We had someone in the SRE team that had worked in the POC, so there was some history there. And I know that this kind of sounds like a bit of a detail, but there was one ingredient that the SRE team brought that really helped with the rollout. We were much closer to the feature developers than the infrastructure team. And that proximity gave us extra insights on how to bring this technology to the rest of the engineering population. Speaking of the SRE team, we had 5 engineers and we had 1 program manager. Rolling out distributed tracing across multiple teams, multiple departments meant a lot of communication, a lot of coordination, a lot of cross-team alignment, cross-department alignment. And we were really lucky to have someone that could help us navigate all of that. So whenever you're faced with endeavor of this scope, you should definitely get someone that can help you navigate all these challenges. Okay, so like I said, we wanted to roll out distributed tracing across the entire company. It's a large company. Most large companies have a lot of high priority projects, and they all want help from different teams. And now here we are. You say, hey, everyone, you need to do this thing for us. Most of the teams that we needed help from were dealing with 1 to 3 number 1 priority projects, and we said, hey, work with us. That would not work, so we needed to get their attention. Fortunately for us, there was something that would help us get our leverage. There was one high priority project that was on almost everyone's table where we could piggyback on, and that was that year's Cyber Week preparations. What does Cyber Week and distributed tracing have in common? Well, Cyber Week is a week of high traffic on most e-commerce systems. The impact of an incident during that week is going to be proportional in terms of impact on revenue and reputation, so you really want to get this right. And because it's high traffic, you will have to scale your platform to a level that is many times its typical scale. But the scaling part can be challenging because in our case, we had traffic estimations at the edge, and we needed to translate that to scaling guidance for teams and their distributed systems. All right, so how do we go from traffic expectations at the edge to concrete scaling guidance for individual services? Well, first you need to have a target, so you have traffic expectations, you're gonna have to scale, we're gonna have to do some load tests. Well, distributed tracing will reveal all the systems that participate in a transaction. You look at a trace and you can see this service, then goes to that service and goes to that service. And this is very useful to know, okay, these are the systems that need to be scaled. Now, you're gonna have to run some load tests to make sure that the scale that you're targeting will match your traffic expectations. So when you're running load tests, distributed tracing can also be very helpful in identifying bottlenecks. So this was our pitch. We said, okay, we can help you with the load tests to get concrete guidance. We also had another argument, which was because we had a struggling metrics tool, Cyber Week traffic might risk overrun that tool, so tracing is not going to replace metrics, but we will provide an alternative source of visibility. Okay, we found our sponsor project. We got everyone's attention. Time to go and meet the teams. The rollout, we brainstormed a bit how to approach this, and we figured out that we had to cover 3 aspects. Teaching, we wanted engineers to know how tracing works so that they can use it to visualize their the operations that go through their services, and also be comfortable instrumenting. We have to instrument the applications as well, and we had to change processes to collect the benefits of open tracing, or distributed tracing in this case. I get that the teaching going around to an organization of over 1,000 engineers may sound a bit slow, and it was in the short term, but we were optimizing for knowledge distribution and to also be able to scale our efforts. We wanted the engineers to look at tracing with confidence instead of distrust. This last point is kind of key. Distributed tracing was not going to fix anything by itself. So you need to bring tracing to where it can actually bring benefits. And what were our ideas for all these 3 points? For teaching, we designed a workshop covering open tracing basics and hands-on instrumentation, pretty much the content that we brought here back in 2019. Instrumenting, well, this was not many ways around it. We have to instrument the services, but we did have one guiding principle, which was we wanted to see some value early on. And changing processes, that's where we started. We started with a problem, so we wanted to improve observability, and we wanted to facilitate incident troubleshooting. And of course, there's also our commitment to our sponsored project and the Cyber Week load test. So at this point, we kind of have 3 different angles. They overlap a lot, but there's still something missing to really bring them together. So we need to have a broad adoption of distributed tracing. That was like the main goal, the point. We have the rollout goals, those 3 points that we want to cover, and our commitment to the Cyber Week preparations. And the ingredient that was missing was a change in how we would see instrumentation. So we went from a goal of instrumenting applications to instrumenting customer operations. Why the change? There were 2 main reasons. One was the load testing of the critical user operations for Cyber Week, and also open tracing guidance, crawl, walk, run. So what is this critical user operations? I mentioned the traffic estimations at the edge. So these were estimations on things like number of orders, how many people are going to be browsing the catalog, how many stuff will be added to carts. So together with other seasoned engineers in the company, we looked at those predictions and we tried to map them to operations that customers would do on the web store. And say, okay, so these expectations will match these operations, so we're going to be load testing these operations, we test them at the edge, and we see how the rest of the platform can handle the load. So this means load testing, and because we want to help the load test by having tracing data available, these are the operations that we will be instrumenting. Regarding the workshops, well, we were going to run the workshops with the teams that own the services that contribute to these operations. From the open tracing guidance, great piece of documentation. I just copied a small quote. The greatest value is going to come from building just enough coverage to generate end-to-end traces, so you cover the whole operation, for some number of high-value transactions, or critical operations. It is important to visualize your instrumentation as early as possible, and this mapped well with our guiding principle for the instrumentation bit. So I really cannot overstate how fundamental this list and the criteria was to the success of the project. It tied everything together. It's what allowed us to work on something that was concrete, achievable, in line with our goals for the cyber week preparations, and through that got management support all the way through. It's also what allowed a small team to have a big impact, because usually when you roll out the technology in a large company, the team doing the rollout is small. We were 5, we had also support from the monitoring team, but we're still working with over 1,000 engineers. So having a plan, having concrete goals, what allowed us to maximize both the use of the technology and also through the rollout gain some momentum to achieve wider adoption. Speaking of momentum, that turned out to be a very important ingredient. So this work was done over a period of almost a year, the rollout specifically, and in that time, people will be distracted with other things, they might get bored with the subject, so you need to keep them motivated. You need to keep yourself motivated, and you need to keep making progress on the rollout. Okay, so to kickstart that momentum and to kickstart the instrumentation, we thought, we need to show people what they can get out of this. So what if we instrument 2 of these critical operations? They have to be simple enough that we can instrument it ourselves, and then we'll just ask the teams to do the code review. And this made everything a lot easier because we're instrumenting operations instead of applications. We don't need to cover the entire application. We just need to cover the code paths that implement that operation. Fun fact, the teams actually at one point started looking at those early traces and they started saying, oh, this is cool. And then they said, move out of the way, we'll take it from here. Thank you for your help. So this was actually very motivating for us because through that first contact, through those first traces, we saw that people were interested and that they could use it. But we did more things to generate this momentum. So other than repeatedly showcasing those initial operations, we also came up with a semantic conventions working group. We were building things on top of open tracing semantic conventions, other semantic conventions and best practices that were more custom tailored to our organization. We started collecting success stories of how other teams were using tracing, how they were identifying problems and solving performance issues, which was really useful because some teams would be like, what tracing? It improves observability. What do I do with that? Well, here's a list of things that you can do with that. The SRE team ran the SRE guild, so we promoted tracing heavily in that guild. We brought people to present their success stories that we just mentioned, and we would remember people, hey, tracing, and try to promote the rollout. And we also early on started asking for traces during incidents and in postmortems. which was made possible because, again, we focused the instrumentation part on building value early. And this was fundamental to get also some benefits earlier. And through those benefits, we could then generate more momentum. So we could see in a very early stage of the rollout already some traces during incidents. And this would then motivate other engineers to say, okay, this has actually made their jobs a lot easier, so maybe I should do that. So all these things to generate momentum, what were the reactions that we got from the engineering community? Pretty diverse. Some were excited, others were just, oh, let's see where this will take us, but they still gave us the benefit of the doubt. Others would work on it, but just to tick a box, okay, I did something, I'm done. Others just ignored it, they just waited for us to go away. And others were really opposed. So as you can see, not every reaction here is exactly positive, which is why momentum is also very important so that you can overcome this resistance. But now I'd like to talk a bit about the open opposition that we got. Again, some people were really opposed to tracing. Either because they claimed they do not need it, they did not like how the code would be with the instrumentation code, or because they thought it would bring problems to their services. I think these quotes can showcase really well how sometimes we cling to certain tools and we disregard other tools, new tools that can bring other benefits. I think it's important to acknowledge that new technologies will have a big impact, or definitely can have a big impact on the things we do every day. And that impact can actually seem threatening. I mean, sure, you have great intentions, you're out to solve a problem, but others will think, what, are you taking the other thing that is so important to me? Now, you can't win them all, and we certainly didn't. But I would definitely recommend that you address any kind of detractor that is a key element in a given area of the company, like a team or a department. This was a minority, a vocal minority, but it was a minority. But there were some detractors that we had to engage with. And in some cases, it was actually a big win because we turned a key detractor into a key promoter. So are we done yet? Pretty much. Also because the rollout was attached to the Cyber Week preparations. Cyber Week was prepared, Cyber Week came and gone, so rollout is done. Post-rollout, tracing data became a primary tool in incident handling. New services became bootstrapped with open tracing instrumentation right from the start. We developed some new tools based on open tracing data, an alerting tool, a new SLO framework, automatic service diagram, a traffic estimation tool, which came really handy for future load tests. We also automated tracing configuration, which was a pain point, piece of feedback that we got from early adopters. And through all of this, what did we learn? So personally speaking, this was a very exciting project to work on. It was full of challenges, full of learnings. And it was really rewarding because at the end, we changed how an engineering organization worked. But I'd like you to leave this talk with a bit more than just storytelling. So now let's look at what were the key learnings that we got from this experience. The first thing that I would highly recommend, start by solving a problem or finding an opportunity. When you're out to solve problems, when you're out to enable some opportunity, your work becomes much easier to motivate yourself and others. You don't go to some other team and say, you need to enable this in your service or whatever. You can say, hey, you can solve this problem. Run a POC phase to answer two questions. Does this technology solve whatever problem or enable whatever use case you're looking to enable? And what is the best tool for the job? Again, evaluating a tool can use different criterias. We use those that I presented before. They work well for us. Define a rollout plan that covers education, broad usage, and collecting benefits. Remember to educate your engineers so that they actually use that tool to the best of its abilities. And they don't look at that technology with distrust, like someone is pushing this thing, I have no idea what it is. So this can be tackled with education. Promote the technology to achieve broad adoption. So find some seeds in the company that can help you scale your efforts and also promote the technology in their own space. Again, we instrumented those early operations and we did more things around it to promote distributed tracing. Change or create processes to achieve your original goal, so to solve that problem or to enable that opportunity. Again, if you have 100% rollouts because it's in every service, that's all good, but is it actually changing something to affect the original goal? Find a sponsor for the rollout. You may think that just because you're rolling out and you got some manager to accept this technology, you may find that it still can still be very challenging to roll out the technology across an entire organization. In our case, we found a high priority project that we could piggyback on. Could have been some senior managers that say, hey, I see value in this, come to my org, I will say that this is important, and then you can take that to show some success stories to the rest of the company. The more disruptive a technology is, the more detractors you are likely to find. Be prepared to meet that resistance. Again, you can't win them all, but be sure to address any key detractors. And remember, those can be turned into key promoters. I keep getting back to this because it's just super important and it's what got us through the entire thing. Focus the rollout on adding value. When you're out to solve people's problems, when you're out to enable some use case that can increase the impact of a person in their company, then people are much more likely to hear you than if you are just enable this and it's done, this team is done. So, and it's also a lot easier to motivate yourself because this will take a while. Again, for us it took around a year. And that's it. So thank you very much for listening, and we have time for questions.